I'd like to make a side note about something called complex fractions. So a fraction is where you have a numerator and a denominator. So a complex fraction is where either the numerator or the denominator is a decimal or a fraction itself. So while this is a wonderful fraction that can now be reduced to 1/2, a complex fraction would have a decimal inside the actual fraction itself. So do you see here there's a decimal that's in the numerator? This is not considered a simplified fraction. Complex fractions cannot be your final answer. Complex fractions are not simplified. So you need to take further action to simplify complex fractions so that they are in their fully reduced state, and that then would be an acceptable answer. So this, for instance, is a complex fraction. Here, this is considered a complex fraction. Do you see that there's a fraction within the fraction? So both of these are complex fractions. You can turn them in to regular fractions, but as they are right now, you cannot leave them in this state for your final answer. So how would you get rid of either decimals or fractions within your fraction? Well, let's take decimals. If there's a decimal in your fraction, what you want to do is you want to get rid of the decimal. The way that you get rid of a decimal is that you can multiply by 10 in this case. If it's a decimal less than 1 or 0, you can just multiply it by, in this case, 10 100. So if you multiply 0.05 times 100, do you see I went over 2 decimal places? If you multiply it by 100, then you get rid of the decimal point, you just get 5. So if you multiply the numerator by 100, you get rid of the decimal point, it just becomes 5. Really important, whatever you do to the numerator of a fraction, you have to do to the denominator of that same fraction in order to keep the value of that overall fraction equivalent. So if I multiply the numerator by 100, I also have to multiply the denominator by 100. And so 10 times 100 is 1,000. So this is a proper fraction. It is not fully reduced though, because both 5 and 1,000 have a common factor, that common factor being 5. So you need to reduce it further. 5 goes into 5 once. 5 goes into 1,200 times. So your final answer is 1/200. So this is an acceptable answer. If we had a fraction within a fraction, we could also get rid of that. So let's say we had 1/2 over, I don't know, 6. We had 1/2 over 6. What this is saying is, what I would do is turn this into an actual operations problem. So what operation is happening here? A fraction sign can be interpreted as a division symbol. So you would say this is like 1/2 being divided by 6. So this is like 1/2 being divided by 6. Okay? And so from here, if you were given this, what would the answer to this be? Well, when you have fractions and a division sign, what I would always do is make sure that every single term in the operation is going to be in fraction form. And remember, because of a previous video that we did, any integer can always be turned into its fraction form by putting it over 1. So I just turned 6 into 6 over 1, and that's totally equivalent. So do you remember the keep, change, flip? I could do an entire video just about that. Hopefully you understand the reasons behind why that algorithm works. So, but just to do it quickly here, you do 1/2 times the reciprocal, 1/6, so that's equal to 1/12. So that means that 1/2 over 6 is equal to 1/12. This is a perfectly good final answer. So remember to change complex fractions whenever you have a complex fraction into either a simplified improper fraction or a simplified regular fraction, and then you're good to go.